Hello friends, in this video I'd like to solve the following problem from the Irish Mathematical Olympiad 1998. Problem number 1. We wish to prove that if x is not equal to 0, and x is a real number, then the following inequality is true. X to the power of 8 minus x to the power of 5 minus 1 over x plus 1 over x to the power of 4 is greater than or equal 0. So my hints for this problem, first of all, I'd suggest to consider cases of x negative and case of x positive separately. And after doing that, you can try dividing both sides of this inequality by x squared. It might be helpful. So give it a try and I will see you in a minute. Okay, so first of all, let's consider case number one where x is negative. Well, then it's pretty easy to see that x to the power of 8 is positive because it's an even power. Minus x to the power of 5 is also positive. Minus 1 over x is also positive. And finally, 1 over x to the power of 4 is also positive. So we have, in fact, strict inequality. Now, let's consider second case, when x is positive. What happens then? Then, I'd suggest to take our equation, inequality, and divide it by x squared. So we get x to the power of 6 minus x cubed minus 1 over x cubed plus 1 over x to the power of 6 should be greater than or equal to 0. It's what we want to prove, in fact. And now we have some kind of symmetry going on because we have x to the power of 6 plus 1 over x to the power of 6 minus x cubed minus 1 over x cubed. That suggests that we should do the following. So let's take x to the power of 6, 1 over x to the power of 6, and let's put the rest in parentheses. And now the crucial part, if I add 2 and also subtract 2, I will have this part will become x to the power of 3 plus 1 over x to the power of 3 squared minus x to the power of 3 plus 1 over x to the power of 3 minus 2 should be non-negative. And now we can make some kind of substitution. So let for example, y equal x to the power of 3 over 1 to the power 1 over x cubed. Okay. Let's notice something, that this number, we can do the following trick. We can add and subtract 2, and we get x, and let's see, x to the power 3 over 2 minus 1 over x to the power 3 over 2 to the second power plus 2. And it's clearly visible that since this number is a square, our entire quantity is greater than or equal to. So we know that y is greater than or equal to. And let's take now our inequality asterisk, and let's substitute y equals x cubed plus 1 over x cubed. Then our inequality becomes this, exactly this. It's a quadratic inequality. We can factorize the left-hand side, and we will get y plus 1, y minus 2 is greater than or equal to 0. And let's look, we have already established that y is greater than or equal to. So both of these parentheses are, in fact, non-negative. So their product is also non-negative. So this, it is true it is true because y is greater than or equal to. And that, so our inequality is identity. It's an identity. It's always true. So that closes our proof. Quotera demonstrandum. And one last remark before you go. When is equality actually attained? Well, it's pretty easy to see that in cases where x was negative, there was always strict inequality. So if in this place equality is to be achieved, given that y is greater than or equal to, we see that to attain 0, y must be equal to. And that happens, we can see here, that exactly happens when x equals 1. So in fact, we know, so it's a remark, let's write it, remark x to the power of 8 minus x to the power of 5 minus 1 over x minus plus 1 over x to the 4th power equals 0 if and only if, in fact, x equals 1. It's a byproduct of our reasoning. Okay, so thank you for watching. I hope that you learned something and see you next time. Bye.